Okay, today, just kind of a new concept, but not really new because you've kind of been doing this in a sense already, just a little bit in a simpler version. Okay, you're going to find the area between two curves. In the past, you've been finding the area between a curve and the x-axis. Okay, now we're going to find the area between two curves. Okay,
So
well,
what I just said.
let's say that this function here is our f of x function, and this function down here is our g of x function. And I want to find the area in between them,
At point A.
okay, from A to B. I made the picture a little bit more complicated than maybe what the book does, because the book had both functions entirely above the x-axis, but it's going to work here in general too, okay? In order to find the area between the curve from A to B, between the curves from A to B, all right, what you can do is you can subtract the two areas from one another. You can find the area under the curve of f of x from A to B and subtract the area under the curve of g of x from A to B to figure out the area between the two of them. Okay? To give you another little picture, instead,
Which, for g of x, wouldn't it be above the curve, not under?
if I want, let's say this was f, if I found the area under the curve from A to B, that would give me all of this. I'll use a different color here for your sake.
Okay, I see.
If I found the area under the curve from A to B of f of x, that would give me all of that. If I found the area under the curve of g of x from A to B, that would give me this much. So if I wanted to find the area that's between those two curves, I could take the answer to the blue one minus the answer to the red one, and that would give me what's left over, right?
Okay. And even if it's in the negative, it's just
yeah.
subtracting a negative.
You're subtracting a negative is all.
Sweet.
Okay? Area of region between two curves if f and g are continuous and g of x is less than or equal to f of x for all x in the closed interval A to B. Then the area will equal the antiderivative of A to B of f of x minus g of x dx. Pretty self-explanatory though.
Yeah.
Okay. Which again, because it's a minus here, you know, you can split it up into two separate integrals, find the antiderivative of f of x and evaluate that definite integral from A to B. So do that one first and then subtract that one. You can do them separately. All right, just like we have been doing. Yeah.
Essentially, up till this point, our g of x is always equal to 0. Because g of x would be the line that's y equals
Yeah,
0.
y equals 0. Yes.
And thus it's always 0.
Correct.
So we're subtracting 0.
Okay. For purposes of just speed on the video, I'm going to move to the example. I can come back to this, so we just got in here. That way you can get the definition down. Find the area bounded by y equals x squared plus 2, y equals negative x equals 0, and x equals 1.
So 0 and 1 is AB.
Yeah. If you gave me a problem like this with just the two functions, especially as I'm first starting this concept a little bit for the first time, I would probably draw a rough sketch to give me a little bit of an idea as to what I'm doing. Okay, you won't have to eventually, but I think right away, especially just to give you a little bit of an idea of what we're going to be doing. Y equals x squared plus 2, that would be a parabola that's been shifted up 2 units. So it's going to look something like this.
Negative x is just
Y equals negative x is a line with a slope of negative 1. X equals 0 is a vertical line at 0. X equals 1 is a vertical line at 1. So what I'm calculating
2.5 plus, never mind.
is the area located right there by that shaded region.
Which we should know should be a little over 2.5.
Based on assuming I've drawn things to scale, yes.
Well, then just, the first part is fairly easy because since it's shifted up 2, then it's, you know there's going to be the 2 there, and then since that's a negative 1 slope, you know that's going to be half.
Yep. So, in order to do this, you're really just finding the area between these two curves. So between the parabola and that line, you're finding the area between those from 0 to 1. Does that visually make some sense?
Yeah.
Okay? How could I write that then using antiderivatives or integrals?
So you can do the integral of, we could say y1. Can we make it y1 and y2 so that it's different?
Let's just use the functions themselves. They're already written up there for us.
Okay, so the integral of x squared plus 2 minus the integral of negative x. Oh, right, because that's the same thing, because you can split that out, so it is, okay.
What about here and here?
1 and 0.
0 to 1, right? Okay? So any questions on that setup there? No questions. Okay?
So it's just 1/3 x cubed plus,
So let's do the antiderivative. 1/3 x cubed
plus 2x
plus 2x.
minus,
That'll be plus 1/2 x squared.
yes,
That's really plus x. So plus 1/2 x squared from 0 to 1. Plug in a 1, you get 1/3 plus 2 plus 1/2. So 17/6, 2 5/6.
sounds about right.
And then you plug in a 0, you get 0.
Wait, 3/6, then shouldn't it be half?
Well, this is 2/6, and that's 3/6, so that makes 5/6, and there's 2, so 2 and 5/6, there's
Sorry, I thought you
17/6.
said 3/6, not 5/6. Never mind, we're good.
17/6 minus 0, which will be 17/6.
Super.
So the area between those two curves is 17 over 6, 2.56, 2.83, repeating bar, I believe. Okay.
Where did you get that last zero?
I had to plug in a 0, right? That's
Oh.
how you do the definite
Yeah,
integral.
yeah, sorry, I was having a moment.
Okay? Alright, so any questions on that? Area between two curves. Okay? Maybe one more. Let's find the area between y equals 2 minus x squared and y equals x. What's that?
So that would be an inverted parabola, right? Or upside down?
Since there's no interval.
Oh, no, we gotta find those.
That would be an upside down parabola,
A little
right?
bit of additional previous work that we gotta do before we can do it. Okay?
That would be an upside down parabola, right?
Yep. So 2 minus x squared is an upside down parabola that's been shifted up 2 units. Okay? So if I want to get real picky, I go here, 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 and here. This would be, I believe, down here, and yep, there. So there's our y equals negative 2x squared. Y equals x. Is a line with a slope of 1. So the area between those two would be all of this right there.
So, wouldn't it theoretically also be between those two on the right side of that as they're going, oh, but then it would equal infinity and we don't want it to be infinity. So, if it were to say, find the area between these, and if it gives us a range, and if all of it's, would that be to the right of 1, I think? Yeah, to the right of 1. Would we consider that negative, or will we just calculate how much would be between it? As in, if it says...
Well, there's a stopping point. There's going to be a finite answer.
Right. But like, okay. So, for that,
Try and make it quick because I'm killing time on this video
okay,
right now.
fine, I'll ask you later.
Okay, yeah. Alright. So, the problem on this one was you didn't have what? The interval from 0 to 1, or from where to where. Okay? Now, graphically, you could probably see now that it's going to be between negative 2 and 1, but you're not going to probably want to graph them all the time. So what you want to do is you want to know when these two functions equal each other, where they intersect each other. Okay? So set the two functions equal to one another, 2 minus x squared equals x, and solve for x. Because you want to know when the two functions are the same. What x values are they equal? So then you know your beginning and ending value you're going to calculate the antiderivative. So 0 would equal x squared plus x minus 2. If I move everything over to the right side, I want to move everything over to the right side because it gives me a positive x squared, and I like factoring with a positive x squared versus a negative x squared.
And it could be 2x
X plus 2, x minus 1. So x equals negative 2, and x equals positive 1. It gives you the x values where those two graphs intersect, and therefore it also then gives you the lower and upper limits that you'll use on your antiderivative.
So you just find the zeros and you find the
I would call them the zeros. I mean, yes, that's what you're doing here, but they're not really the zeros of the original functions. You're finding, the better way to put it is, you're finding the x values where those two functions meet. The points of intersection, if you will. Not the points, just the x values. You don't need the actual coordinates. Okay? So then, you could set it up. I want to find the area from -2 to 1 between those two curves. What curve is always higher than the other one? Which one?
2 minus.
The 2 minus x squared. That's the other important thing, okay? Make sure the one that's further up, you do first, okay?
But tech,
You'll get a negative if you don't.
right, I mean, oh, higher up on the interval here, you said, okay, never mind. We're good.
So you'll find the area between this curve and this curve from -2 to 1. So again, be similar type antiderivatives. I'm not going to go through it right now, just for time purposes on the video. It's going to be very similar. This answer ends up being 9/2. The answer should be 9/2. The only other thing that I can think of before I stop the video here is if the curves were to intersect at more than 2 locations. So you would have to find this x value, you would have to find that x value, and you would have to find that x value. Do the problem from here to here, and then do the problem from here to here.
So you always
Now-
use the graph first?
Probably give you a pretty good idea, yeah. The thing that you got to be careful on is from here to here, this function's higher up, so you do that function minus that one, and it's the other way around on that other interval. So you just got to be careful on that, okay? It's the same sort of concept.
Or you just always gonna look at the
Depending on, not necessarily depending on where the x-axis is potentially too, I
Don't ask
believe.
dumb questions.